TikTok dance I will be analyzing will be See You Again, Alternate Intro by Tyler, the Creator. It became very popular at the end of 2023. I will let the dance play, then I will analyze it after. Here is the analysis. So in the beginning, we start with simple movements with the wrist, and then he flexes one leg inward and the opposite outward. Then he does a little shimmy, then alternates the leg and the arm, each bicep. We then are led to where he goes back, sort of flexes both biceps at the same time, and alternates side to side, bending his knees just a little bit. He extends one arm fully out and flexes his bicep again, and alternates between the movements like a plane. He does a spin motion. Then he alternates between putting both arms in and out, and then salutes.
At the beginning of the dance, there's contraction of the trapezius muscles in the shoulder shrug at the beginning. This could also involve the deltoids and the infraspinatus muscles. They connect to the scapula. The flexor carpus radialis, flexor carpus ulnaris, and the palmaris longus are contracted in the flexion of the wrist at the start of the dance. These muscles are connected to the metacarpals. The right leg is slightly lifted off the ground here, which is created by the contraction of the hip flexors, the rectus femoris, iliopsoas, and the sartorius muscles, which are attached to the patella and the femur. Next, there is adduction of the arms here. The muscles in this motion that are used in this motion are the pectoralis major, the latissimus dorsi, as well as the teres major. The humerus is attached to these. Next, the arms move back out, which is abduction, and the muscles used here are the trapezius, supraspinatus, and the deltoid. The scapula is connected here. The next movement is when the bicep and the forearm flex closer together, and this would be flexion. The muscles used here are the brachialis, biceps brachii, and the brachioradialis. These are attached to the scapula as well. The leg moves in a similar fashion, so I would call this flexion. The muscles here are in the hamstrings, sartorius, and gastrocnemius. This is connected to the pelvis. Next, the feet begin to shuffle in and out, which I would call rotation. The tibialis anterior, extensor hallucis longus, and the peroneus tertius are used here. These are connected to the metatarsals. Here, there's a bit of rotation in the upper area of the arm. I would say that the supraspinatus, infraspinatus, and the teres minor are used here. The humerus is connected. He then snaps in this motion, which he would use the flexor digitorum profundus and the flexor digitorum superficialis to do this. The ulna is involved here. He then moves his arm in a sharp outward motion, which I would also consider abduction. He uses the deltoid, supraspinatus, and the trapezius to do so. The scapula is here. He then leans back a bit in this part, which he would use the iliocstalis muscles to do, as well as the spinalis. The vertebra is obviously connected here. He stands on his tiptoes a ton in this dance. In order to do this, he must use his plantaris muscle, gastrocnemius, and the soleus. The calcaneus bone is connected here. He spins around towards the end of the dance, which definitely works his gluteus maximus, rectus femoris, and gastrocnemius. The calcaneus bone is also connected here. Finally, he salutes at the end, which is a flexion of his arms, clearly using the brachialis, biceps brachii, and brachioradialis. The scapula is here.
In these screenshots, we can see how one bicep is flexed and one is relaxed. By flexing, I also mean contracting. While they are contracting and relaxing, this is because it is attached to skeletal muscle. And there is a joint with the knee and the elbow, which is a hinge joint. There is also the ball and socket joint moving, because his shoulders do move while he's sort of bringing his arms up in the dance. We also have a little bit of the saddle joint, because he does snap his fingers. And while talking about the hand, there is the epicilloid joint, where he does move his wrist in the beginning, and the pivot joint is a little bit, because he does move his head a little bit.
Finally, we need to discuss how muscles contract and relax. The basic mechanism for muscle contraction and relaxation is known as the sliding filament theory, and it involves the interaction between actin and myosin. First, the process begins with a nerve signal reaching the neuromuscular junction, where acetylcholine is released. This action results in the action potential traveling along the muscle cell membrane and into the T-tubules, triggering the release of calcium. Then, the calcium will bind to the troponin, a protein on the actin filament, which causes a change that exposes binding sites on the actin. After that, the myosin heads, which are part of the thick myosin filaments, they bind to the exposed sites in the actin. After that, ATP becomes involved, and it provides energy for the myosin heads to undergo the next part of the muscle contraction, which pulls the actin filaments toward the center of the sarcomere. This repeated cycle of cross-bridge formation and the ATP working to pull the actin filaments leads to muscle contraction. For muscle relaxation, that nerve signal that was used for muscle contraction, it releases or ceases, which leads to the stop of acetylcholine release. After that, the calcium ions are actively transported back to where they came from, reducing the concentration of calcium in the cell. As calcium gets away from the troponin complex is reestablished, which blocks the binding sites on the actin. With the binding sites of the actin blocked, the myosin heads can finally detach from the actin. Now the cross bridge has been detached, and the sarcomeres can finally return to their resting length, and the muscle is relaxed.